In this example, we're going to investigate whether or not functions are one-to-one. So recall the definition of one-to-one from your text. One-to-one is talking about the relationship between the input and the output of the function. So remember, in order to be a function, each input, or x value, corresponds to only one y value. Now, to be one-to-one, it is also going to be true that each y value corresponds with only one x value. So to summarize that relationship, if a function is one-to-one, then that tells you that two different inputs will not have the same output. If your two inputs are different, then they should correspond to two different y values. So again, each y should only come from one x if your function is one-to-one. So I have a few examples here we're going to look at. So let's say I've got some functions being represented by a mapping. So I have a function here and a function here, f1 and f2. And function 1 is definitely one-to-one, while function 2 is not. The y value of 1, or the output value of 1, corresponds with two different input values, which means this is not one-to-one. It also happens several times during this function. So it is a function because each input corresponds with one output, but it's definitely not one-to-one. This, however, is definitely one-to-one. So what if instead of a mapping, I represented a function using a set of ordered pairs? So here I have two more examples. This function is defined with these ordered pairs, while this function defined with these. So let's say this is the function g1, and this is the function g2. So we can confirm that they are functions because each x-coordinate corresponds with only one y-coordinate. There is no repeated x value in any of these. And you can see in this first example that each y value corresponds with only one x value. In other words, there are no repeats of the y coordinates. However, in the second example, you can see the y value of 3 corresponds to two different x coordinates, and the y value of 6 corresponds with two different x coordinates. So this second example is not one-to-one, while this first one is. Again, what I'm looking for here is whether or not the y coordinates repeat. And in this first example, there's only one instance of 8, 5, 2, etc. While in the second example, there are repeated y values. So this is not one-to-one because of these points. So another way we could represent a function is by using a graph. So I have two more examples here. Let's say we have functions h1 and h2. So I want to use the same idea as up here, right? I don't want repeated y coordinates. I need each x to go to one y in order to be a function, and I need each y to come from one x in order to be one-to-one. So if I just look at the y value of 2, all along here, this has y value 2. And you can see for the y value of 2, there are two coordinates on this graph, which means there are two x values that correspond to this one y value, which means this function is not 1 to 1. While this function over here, if I look at y equals 2, we can see that there's only one coordinate on this graph that has a y value of 2, and it corresponds with this x value right here. And we can see that this function is 1 to 1. And we can confirm that using what we call the horizontal line test. So as you can see, these are horizontal lines drawn in here. So for the graphs, we use the horizontal line test. To determine if the graph is 1 to 1. So what we're going to do is just draw in any horizontal line, and it should only intersect with your graph at most once. And as you can see, this horizontal line intersected the graph twice, meaning it's not 1 to 1, while any horizontal line I could draw in here would only intersect the graph once, means it's 1 to 1. So it's all about that correspondence between your input variable and your output variable. We want this to be one x with one y, not another x with the same y.